Hi, we are Group 3, and today we will be discussing the economic feasibility of internal Apple Ascorbic acid design project. Now, the idea for designing this project comes from the recent events pertaining to the COVID-19. As more and more people have become more health conscious and have become more wary about their health in general, more and more people have decided to avail different supplements and vitamins. And s- uh, we saw that there is a large market for vitamin C because, as referenced in from table 3, we see that largely most of the vitamin C is imported. And given that the vitamin C for people to intake requires about 2 milligrams a day, which is 0.73 kilograms a year, and in addition, it cannot be produced within the body, we see that there is a opportunity here and a possible lucrative one. As such, we designed this project. Now that we saw that there is a viable market here in the Philippines as well as globally, we then conducted a market analysis as to further understand how large is the market for vitamin C or ascorbic acid here in the Philippines or globally, and is there really a place for this project to prosper? And we done this in a way that we projected a supply and demand, among other things, to quantitatively grasp how large is the market here in the Philippines and what is the capacity that a plant can have. And as we see here in the slide, that there is a large gap between the supply and demand. As such, we saw that to further this venture and to have a processing capacity of 2% of the needed demand of the country as well as globally. Now, to be able to fully understand the cost or the equipment's use or the maybe the number of labor or people that has to be used, we then have to understand the processes and the equipments that will entail this project. The process flow diagram is a good diagram to depict all of this. Now, in this initial stage or the first segment of the process flow diagram, it can be seen that in this segment is the conversion of the raw material into the ketogluconic acid. And this process spans from the fermenters, which is acronym as FR, up to the IE100, which is the ion exchanger, which converts the sodium ketogluconic acid to ketogluconic acid. And the filters, as well as the evaporators utilized within this section of the process, is to help remove any unnecessary byproducts and harmful vapors that may endanger not only the equipment but the people working within the facility. And for the second section or the last section of the process flow diagram, we can it is here that the ketogluconic acid is converted to the ascorbic acid that we know and formed into solids and into the pills that we see in the market. And the conversion of ascorbic acid is done during the SR100 up to the IE100, which is the ion exchanger 101, and starting from the continuous stirring reactor, first stirring reactor. It is here then passed through the evaporator, which removes any wet or unneeded uh, byproducts into vapor, move on to the crystallization of the product into the molding, and to the removal of any excess water vapors up to the storage of the product.
Good day, I am Jumola Decanlas, and in this section, I'm going to discuss the calculation for the equipment costing and for the capital investment. So, in this table, the proponent utilized chemical engineering plant cost index for the evaluation of the process equipment. So, this table summarizes the costs from year 1996 up to year 2022. So based on the findings, using SEPSI analysis, most of the price of the process equipment essentially increases from year 2014 up to year 2022. So in this slide, we can see the projection graph of the chemical engineering plant cost index that displays an increase regarding to its values and forecast. So this means that each of the process equipment relatively increases with respect to its year. So basically, the proponents also utilize an equipment cost calculator for each of every equipment. This equipment calculator can only cover the prices from year 2014. Hence, this is the ratio that we use to convert the values to the target year. Consecutively, this is the sample calculation for the ultrafilter, and using the table for chemical engineering plant cost index, we can now have the SEPSI value for year 2014, which is 576.1, and for year 2022, which is 640.79. So by solving this simultaneously, we can calculate the cost of the process equipment for the target year, which is year 2022, as you can see on this slide. On to the next, we'll be discussing the capital investment that must be allocated as a capital for the initial expenses. So this is the tabulated TCI, or the total capital investment for our plant. This includes the direct costs and indirect costs that will be used as a basis to calculate the fixed capital investment, or the FCI, as well as the working capital, or the WC, to get the total capital investment, or the TCI. So with this value of TCI, we can now set this as a cornerstone in establishing the plant before putting it into operation. So we base the calculation of the total capital investment from Timmerhouse Plant Design Book, that is basis for the total capital investment. Since our process falls under row number 2, which is the solid fluid processing plant, these values are what we utilize for the calculation. In order for us to calculate the fixed capital investment, there are lots of factors that we must need to consider. And as you can see on this slide, these are the values that we will be utilizing, from purchase of the equipment up to the service facilities. With that, we can now solve the total direct costs, and from engineering and supervision up to contingency, we can now evaluate the total indirect costs. So by applying the formula of the FCI, by adding both of the necessary value, we can now calculate the fixed capital investment, or the FCI. So for the calculation of the working capital, it is multiplied by 75% of the delivered equipment, and from that we can now evaluate the WC, or the working capital. So for the calculation for the total capital investment, by adding simultaneously the FCI and the WC, we can get the total capital investment, which is $28,852,000 US dollar.
I am Jabril Young, and I will be reporting on the annual product cost and annual sales. This table shows the summary of product costs. The price in dollars per year is multiplied to the annual amount in million kilogram per year to obtain the annual value in $1,000,000 per year. The main product obtained an annual value of $158.34 million per year. With this, the total annual value of products, which is $158.34 million per year, was obtained. Here, the annual product cost at 100% capacity is shown. The cost in $1,000,000 per year is shown at the rightmost part of the table. The factors and bases used for the cost are also shown. As said a while ago, the basis and factor was multiplied to obtain the cost. The variable cost was obtained by summing up the operating, supervision, maintenance and repairs, operating supplies, laboratory charges, and royalties. For the manufacturing costs, it was obtained by adding the variable cost, fixed charges, and plant overhead. Next, we have the sample calculations for the general expense. The general expense was obtained by summing up the cost for the administration, distribution and selling, and research and development. Then, the calculation for the total product cost is also shown.
Pleasant day to everyone. My name is Hazel Banil and I'm here to present the cash flows of the proposed plant. So, for this figure, which is the cumulative cash flow versus the plant service life, at year -2, this signifies the beginning of the construction phase, and therefore there will be cash outflows as required for the construction of the plant. This cash outflow consists of the fixed capital investment, which, is also equal to the total capital investment. It is also important to note that land is not included. Now, there is a decrease in the slope of the curve. Why is that? This is because there is an increase in the total cash outflows due to construction inflation rate of about 0.02. Then at year 0, this is where the startup of the plant begins, the startup of the operation of the plant. And from year 0 to 1, we can see a positive increase in the slope of the curve. This is because there are cash inflows coming from the sales of the products sold. However, we are still on the negative part of the diagram because we are still spending money for the product cost, for the manufacturing the product, and that the gross profit is not is less, much less than the total capital investment made here on year -2. It is also important to note that depreciation is subtracted during these few years. However, the slope continues to increase as a result of an increasing number of sales in terms of the $1 million of sales. And then at year 3, it is where the gross profit is equal to the total capital investment made. During these years, we can see that the slope, that the curve is already in the positive side of the diagram. This is because the sales or the profit is much larger as compared to the losses or to the cash outflows. So cash inflows are much greater than the cash outflows during years 4 to 10. Further analyze the profitability of the plant, we're going to solve these following values. So using this formula for the return on investment, we will obtain a value of 12%. Now, this 12% is much less than 15%. 15% is the minimum rate of return. When the ROI is much less than the minimum rate of return, this only tells us that there are great losses done during the span of the operation of the plant because total costs greatly exceed total returns of the money, of the cash. As for the payback period, using this formula here, we have obtained a value of 4.1 years, which means that uh, it is it takes 4.1 years for the plant to recover the initial cost of an investment made. Therefore, it was 4.1 years before we can actually equalize the gross profit gross profit and the investment made during the first few years. So for the net return, using this formula, we've obtained a value of -0.89 times 10 raised to $6 million, or rather $0.89 million. Now, what this negative sign tells us is that we have experienced a financial loss, or rather, we have some losses in terms of the cash instead of profit over over the plant service life, which is about 10 years.
In conclusion, the following could be said. First, the company has a fixed capital investment of $24,550,000 and a working capital of $4,302,000. With this, the total capital investment is at $28,852,000. Next, the total annual costs were summarized. Here, we could see that the total product cost without depreciation was calculated to be $126.671 million per year. With the data obtained from the study, the return of investment was calculated to be at 294.8%, which means that the investments were properly managed and a great amount of return of investment was obtained. Next, the payback period was determined to take 0.3 years. With the payback period being less than a year, it could be determined that there will be a profit for the project for the first 10 years of the plant's life. Lastly, the net return acquired is at 83.98 times 10 raised to $6. This shows that the project would acquire gains, which depicts profitability for the first 10 years of operation.